Hello, I'm Lily, and my physics problems that I'm going to solve goes like this. A freezer needs to be cooled to an average temperature of minus 168 degrees Fahrenheit. How many degrees Celsius is this temperature equivalent to? So, we are going to cover the data, which are F for Fahrenheit, and it has temperature of minus 168 degrees. And we want to find the centrifuge, so we'll take this formula. Now, let's do the operation. And as that's the formula, when this us, we are going to point the worst Fahrenheit that this indication to us the problem. Minus this 32 and we close parentheses, then y.15x. Now we do the operation that is negative. 168 negative 632, which gives us negative 200. And we are going to point the amount he gave us the parentheses, and next to it we will divide it by 9. Then we do the operation that will be minus 200 times 5 between 9, and the result is minus 111.1 centigrade. And so we finish.
Hello, my name is Alondra and my problem is the following. A balloon was filled with 4.4 liters of helium to a temperature of 26 degrees Celsius and cooled with liquid nitrogen to minus 194 degrees Celsius. What volume would it occupy if the pressures remains constant? Our data are the following: initial volume 4.4, initial temperature 293 Kelvin, and final temperature 79. The formula we will use is final volume equal to final temperature multiplied by the initial volume divided by the final temperature. Now we will replace the data. Final volume is equal to 79 times 4.4 over 204, leaving final volume equal to 413.6 over 293, resulting in the final volume 1.411.
Hi, I am, and the problem is as follows. A car starts with a caliber 2 for 3 pounds per inch in the afternoon, when the temperature measures 18 degrees Celsius. If at night it is 22 degrees Celsius, and the tires will increase in the pollen from 58 to 72 pounds when measured with the half. Start with writing down the data always has such as initial volume, which is 58 pounds, the initial pressure, which is 40 pounds in each, and the not initial temperature, which is 18 degrees Celsius. Note the final volume is 58 pounds, the final temperature, which is the 22 Celsius, and there we realize that what the looking for the temperature 291 Kelvin and the final temperature of 295 Kelvin, and we can start solving. The formula we will be final pressure equal to initial pressure times initial volume times final temperature divided by initial temperature times final volume. We replace the formula with the dot, leaving the formula pressure equal to 43 times 15 8 times 290 50 divided by 291 times 72 735,730 out of 20,952, and the end result will be 33.11 pounds per inch.
Hello, I am Angel and my problem to solve is the following. The air in a steel cylinder of constant volume at 40 degrees Celsius has a pressure of 6 atm. If the cylinder is heated to 60 degrees Celsius, what will be the final pressure of the air? Now we will to collect the data to using initial temperature of 40 degrees, final temperature of 60 degrees, final initial pressure of 6 atm. After this, 273 will be added to degrees Celsius to make the degrees Kelvin, so the initial temperature will be 330 Kelvin and the final temperature will be 333. Now we will use the following formula. Already solved previously, final pressure is equal to initial pressure times final temperature between initial temperature. Now we will substitute the values will be final pressure is equal to 6 times 333 times 313. After this will solve the operation. We will multiply 6b 333 and the result will be 1998. Then we will divide 998 by 330 and the result will be 6.38 atm, and this will be the final pressure of the air.